Well, we had a request for a tutorial on how to use the Smart String SSC firmware that goes on to Smart String controllers 1, 2, and 3. And so I thought I'd make this quick video to show you how to use the software control panel as well as the firmware. You load the firmware either using a Picket 2 or a Picket 3 onto your SSC, and there's a jumper that's on the SSC that's typically used to program, but that jumper is no longer used to program on the altered firmware. The jumper basically is used to tell the processor whether you have made the modification to an SSC 3. If you've taken a SSC 1 version 1 or 2 and converted it to SSC 3, then you'll have the jumper taken off. So if you have not done the conversion and you're still running SSC version 1 or 2, then you'll leave the jumper on. Excuse me. If you've done the modification, then you'll take the jumper off. So that's the only purpose for the jumper, so make sure that you have that connected properly. Once you've flashed the firmware onto the SSC, you'll want to open up the Smart String grouping firmware or software, and you'll be presented with two methods of communicating with the actual SSC, either the Ether dongle or the serial connection. Pick whatever connection you prefer or that you're using. If you pick the Ether dongle method, you'll be presented with the LAN interfaces that are on your computer, so pick the right LAN interface. Typically you probably only have one. I have two, so I picked the correct one that's the Ether dongle is connected to. And defaultly there's a programmer or a SSC already defined. You could change the name of that. For instance, you can call it Roofline or anything else you want. The idea is to create as many controllers as you have in the that you physically have. So you would set the current start channel and the new start channel, and then you'd set the node count, which in this case we'll say 120. You'd pick what type of device it is, and I will pick the TM Flex Strips DLA 1809s, and then of course you have your direction, and then you have your group mode and your custom grouping mode. Right now we'll go over the standard grouping mode. Standard grouping is when you want all of whatever you set the count to, the group count to. For instance, right now it's at 10. Standard grouping means that all the groups will be with a group count of 10. So if you wanted to, for instance, have all the groups be 3 nodes controlled by each RGB channel, you'd select 3, and then you would select standard grouping, and the whole strip would then be broken up into 3 nodes per group for the whole strip. That's what standard grouping is. Custom grouping now is where you have the ability to create custom groups, and I believe I added up to 30 custom groups. So for instance, if you had a strip that was a window going around a window and it was 120, you could divide that up into 4 groups if you wanted to, or 30 groups, up to 30 groups. So we'll add 4 groups, and for instance, say the sides, 2 of the sides were 20, so that would be 40 nodes, and then we got 120 nodes, and then the other 2 were 40 each, because let's say the window was a little bit shaped differently and you wanted to control it in 4 different sections. You would then set it to that, and now you've split up those 120 nodes to be the first group to be 20, the second group to be 40, the third group to be 20, and the fourth group to be 40. This comes into handy also when you're doing like animated faces. It's really good. For instance, your eyes could be, the amount of nodes around the eyes could be a different number than the amount of nodes around the different mouth movements. so you could set up different groups to do that. So it comes in handy also for Eves and many other devices. Last year I used it to create Z trees where the bottom had more nodes than the middle, because there's a bigger circumference. So the sky's the limit basically on, well, not the sky, there's actually 30 groups, so you have up to 30 groups that you can define on a single string. And that's the way that works. So once you have that set up, if you wanted to program it, you would hit program. Now this software has the ability of programming in the field, so if you know what the current address is, you could basically place that in there, and only this SSC will listen to that command, only the SSC that has a start channel. But when you first actually set up the SSC for the first time, it doesn't have a start channel because you just programmed it. So in order to program it, you'd connect it to the hub all by itself, and you'd click this box, and it says basically, when I press the program button, I want to program every SSC that's connected to that hub. What happens is that the program sends out a special address, which is address 4097, and all controllers on the hub will respond to that address 4097. So when they get that command and it has the address of 4097, they go, oh, okay, no matter what, I'm going to respond to that. So if you did that, this controller then get a current start channel of 1, and the next time you wouldn't need to check that, you could just put in 1. So if on the next time, once I've programmed it, if I wanted to switch it to 5, I would put in what the new start address is, what the current one is, and what I want the new one to be, and I'd press program, and it would program it, and then of course it updates it automatically for the current to be what you had programmed it to be, so it saves it for the next time. The program also has the ability to save the file, so you can go ahead and save the file, give it a name. You just call it controllers or whatever you want, 2012 controller, 2013 controllers, controller 2013, and you hit save, and now it's saved. So as you add more standard controllers, you can then save them, and you have a really good indication of what your controllers are set up to. So the next time you go to control them or to program them, you could just use the settings that were saved there, and you know that you'll be communicating with it properly. One little caveat with the program so far is that everything needs to be on a hub that has the address of 1, or the PixelNet Universe 1. I'm going to alter the program in the future to support it being connected to multiple different hubs, but for now, right now, it just can do only PixelNet Universe 1. So make sure your hub that you have the controller connected to is on PixelNet Universe 1. We support hybrid mode, so if you click this, what happens is the first 3 channels of that controller will control the color of the whole string. So if you send it red on the first 3 channels, then the smart string controller, the whole string will actually turn red. And it's very nice if you're doing a mega tree and you want to run it in full string mode. We have another option called the first RGB channel control mode, and when you're in that mode, you can basically switch back and forth between standard grouping, custom grouping, and on the fly using the control channel. So it's very useful. I'll do another video that kind of shows the power of that, because that's another video in itself. So that's just a little brief example on how to use the Smart String utility and the firmware. Thank you.